Good morning, dear students. In today's lecture, we will talk about the last topic of this chapter, that is types of organic reaction. It is one of the most important topic of this chapter. Now in class 10th, I've taught you about the types of chemical reactions like displacement reaction, combination or addition reaction, then double displacement reaction, and last one was decomposition reaction. But it was the part of inorganic chemistry. But today we will talk about the organic chemical reactions. Again, the organic chemical reactions are of four types. Number one is substitution reaction, number second is addition reaction, number third is elimination reaction, and number fourth is rearrangement reaction. In today's lecture, we will cover substitution reaction, and second one, that is your addition reaction or combination reaction. Now, what is substitution reaction? It is similar to displacement reaction that we have studied in class 10. The definition of substitution reaction or displacement reaction: an organic reaction in which a more reactive group displaces the less reactive group. Less reactive group is displaced by the more reactive group based on the type of attacking group and leaving group. The substitution reaction or the displacement reaction are further classified into two types. First one is nucleophilic substitution reaction and second one is electrophilic substitution reaction. Let us start with nucleophilic substitution reaction. You know the meaning of nucleophile. All electron richer species can be considered as nucleophile. Nucleophiles have the property to donate electron pair because they are electron richer in nature. So what will happen in nucleophilic substitution reaction? A more reactive nucleophile will displace a less reactive nucleophile. Remember the important point? It is one of the most important reaction of alkyl halide or haloalkane, or we can say it is the characteristic reaction of alkyl halide or haloalkanes. So here, for your explanation, just general representation. Rx is the general representation of alkyl halide or haloalkane. X is the halogen atom which is bonded to the carbon atom. Being an electronegative element or atom, X will attract the shared pair of electron towards itself, as a result of which delta minus, that is partial negative charge, will be developed over X atom because it has attracted the shared pair of electron. While carbon will develop delta plus or partial positive charge because the shared pair is moved away from the carbon atom. Now, let us take attacking nucleophile. Here, it will be your attacking nucleophile, while X minus will be your leaving nucleophile. Being a more reactive, this nucleophile will displace X from Rx in the form of X minus, as a result of which we will get product and X minus will be removed. Now, equation or chemical reaction CH3Cl, which is called chloromethane or it is also called methyl chloride, when made to react with sodium hydroxide. In sodium hydroxide, Na is having complete positive while OH is having complete negative because it is an ionic compound, it's a base. So in NaOH, Na plus forms the electrophilic part while OH minus ion forms the nucleophilic part. Cl is more electronegative than carbon, so Cl will attract the shared pair of electrons towards itself, as a result of which delta minus will be developed over chlorine and delta plus will be developed over carbon atom. Now, OH minus will attack over positively charged center, or we can say electron deficient center. It is a nucleophile. OH minus is a nucleophile. So it will be attracted towards the positive charge. So when it will attack over carbon atom, Cl minus will be removed. This Cl minus will combine with Na plus, as a result of which we will get the side product NaCl. And main product will be your CH3OH, that is methanol, or it is called methyl alcohol. So whenever alkyl halide are made to react with aqueous sodium hydroxide or aqueous potassium hydroxide, alcohols are formed as the main product. Then comes reaction number 2, electrophilic substitution reaction. Electrophile attracted towards the electrons because these are electron deficient in nature. So here, a more reactive electrophile will displace the less reactive electrophile. Then the important point. It is the most important reaction of aromatic compounds because in benzene ring we are having 3 double bonds, or we can say we are having 3 pi bonds. Due to presence of 3 pi bonds or 3 double bonds, benzene ring behaves like a nucleophile. Benzene ring can be considered as electron richer molecule because it is electron richer in nature, so it will attract the electron deficient species. So here electrophile will be attracted towards the benzene ring. One of the H atom from benzene, you know it very well, there are 6 hydrogen atoms present in the benzene. Each carbon atom is having 1 hydrogen atom. So any of the hydrogen atom from the benzene ring will be removed in the form of H plus, and this electrophile will attack over carbon, as a result of which we will get the product. One of the most important reaction is nitration of benzene. Now, what is the meaning of nitration? Whenever NO2 group is introduced in the benzene ring, then the reaction is called nitration of benzene. And for carrying out nitration reaction, we will be requiring nitrating mixture. Nitrating mixture. Now, what is nitrating mixture? Mixture of concentrated H2SO4 and concentrated HNO3 is called nitrating mixture. When concentrated H2SO4 is taken with concentrated HNO3, then electrophile generated here is NO2 plus ion, which is called nitronium ion. It's plus here, so suffix will be -ium. So the mixture produces electrophile NO2 plus ion, which is called nitronium ion. So this nitronium ion will attack over benzene ring, and when the attack takes place, one of the H from here will be removed in the form of H plus ion, and NO2 group will form the bond with the carbon of the benzene ring, as a result of which benzene will be converted to nitrobenzene. So again, nucleophilic substitution reaction or nucleophilic displacement reaction is one of the most important reaction of alkyl halide or haloalkane. While electrophilic substitution reaction or electrophilic displacement reaction is the most important reaction of benzene and other aromatic compounds. Second case is your addition reaction. It is similar to combination reaction that you were taught in class 10. A plus B gives you AB. So what happens in combination reaction? Reactant molecule react with reagent, as a result of which single product is formed. A plus B gives you AB, a single product. So whenever we will talk about combination reaction or addition reaction, the complete reagent will be added to reactant molecule, as a result of which we will obtain a single product. Now, addition reaction is exhibited by the unsaturated organic compounds. Whenever we are having double bond between the two atoms, it can be between carbon and oxygen, it can be between carbon and carbon. Then the organic compounds are called unsaturated organic compounds. So during this reaction, one pi bond or one double bond will be converted to two single bonds, or we can say two new sigma bonds. Here we are having a double bond or a pi bond. When AB is added, then this double bond is converted to two new single bonds, or we can say two new sigma bonds. So in this reaction, unsaturated organic compounds will be converted to saturated organic compounds. So combination reaction or addition reaction is exhibited by unsaturated organic compounds, and by this reaction, unsaturated organic compounds will be converted to saturated organic compounds. Now, its type. It is of two types. First one is nucleophilic addition reaction, and second one is called electrophilic addition reaction. Whenever we talk about addition reaction, then please remember the addition reaction always takes place in two steps. Step first is your slow step, and step second is your fast step. If in first step or the slow step, electrophile is attacking over the reactant molecule, then the reaction is called electrophilic addition reaction. And if in first step or the slow step, attack of nucleophile takes place, then the reaction is called nucleophilic addition reaction. So what are nucleophilic addition reaction? When the attack of nucleophile is followed by attack of electrophile, the reaction is called nucleophilic addition reaction. What is electrophilic addition reaction? When the attack of electrophile is followed by the attack of nucleophile, then the reaction is called electrophilic addition reaction. Important point. Nucleophilic addition reaction is the most important reaction of carbonyl compounds, that is aldehyde and ketone. While the electrophilic addition reaction is the most important reaction of alkenes. So let us talk about nucleophilic addition reaction. Here I am using acetaldehyde or ethanol, the second molecule of aldehyde, for the chemical reaction. And here we are having double bond present between carbon and oxygen. So it is your it is your reactant molecule, and HCN is your reagent molecule. H is having delta plus, Cn is having delta minus. In presence of this attacking reagent, electromagnetic effect will be operated in this molecule. And you know the meaning of electromagnetic effect. Complete shifting of pi bonds. Complete transfer of pi bond electrons towards one of the atom. So in presence of HCN, electromagnetic effect will be operated between C double bond O, as a result of which pi electrons will be completely transferred towards more electronegative oxygen. As a result of which minus will be developed over oxygen because it is taking both the electrons, while positive charge will be developed over the carbon atom. Now, step first is your slow step. It is slow step because shifting of electrons requires time. That's why step first is slow step. Now, in step first, attack of Cn minus will take place. Cn minus is a nucleophile. So Cn minus will attack over positively charged carbon atom, as a result of which we will obtain this intermediate where negative charge is there over the oxygen atom. And you know the property of intermediates. They are highly reactive in nature. They very short lifespan. So as soon as they are formed, they will be converted into product. So step number second is your first step. In first step, attack of H plus ion will take place. Definitely H plus will attack towards O negative, as a result of which we will obtain CH3, CH, CnOH. These compounds are called cyanohydrine. Cyanohydrine, the organic compounds in which Cn group as well as OH group is there are called cyanohydrine. So nucleophilic addition reaction, attack of nucleophile is followed by attack of electrophile. The reaction is called nucleophilic addition reaction. Then comes your electrophilic addition reaction. Attack of electrophile will be followed by attack of nucleophile. Electrophilic addition reaction is the most important reaction of alkenes. So here I have taken the simplest alkene, that is ethene, CH2 double bond CH2, and it is made to react with HBr. So CH2 double bond CH2 is your reactant and HBr is your reagent. Br is more electronegative than hydrogen. So Br will get delta minus and H will get delta plus. There will be a polar covalent bond present between hydrogen and bromine. Although sharing is there, but most of the part of sharing is taken away by bromine because it is more electronegative in nature. So bromine is having more electron density than the hydrogen atom. That's why delta minus is there and delta plus is there. Now, in presence of attacking reagent, electromagnetic effect will be operated in the alkene molecule. So what will happen in electromagnetic effect? Pi electrons will be shifted or double bond electron will be shifted towards one of the carbon atom. So I am shifting both the electron towards this carbon atom, as a result of which minus will be developed over this carbon and plus will be developed over this carbon. Step first is your slow step, and in slow step attack of H plus ion will take place. So definitely H plus will be migrated towards negative carbon, as a result of which we will obtain CH3 CH2 plus. Again intermediate is obtained. All the intermediates are highly reactive in nature. As soon as they are formed, they are converted into product. So second step will be your first step, in which attack of Br minus ion will take place. So Br minus ion will be migrated towards carbon positive, as a result of which we will obtain CH3 single bond CH2 single bond Br, which is called bromoethane. So unsaturated organic compound is converted to saturated organic compounds. Again, unsaturated organic compound is converted to saturated organic compounds. Attack of electrophile is followed by attack of nucleophile. That's why it is called electrophilic addition reaction. So it's all over about substitution reaction and addition reaction. In the next lecture, we will talk about elimination reaction and rearrangement reaction. Thank you.